All right, good morning. Welcome to the sixth annual Plato MI3 Academic Conference. I'm Mike Bellaro. I'm the CEO of Plato Partnership. Plato Partnership is a not-for-profit company comprising of asset managers, broker-dealers who are collaborating to bring creative solutions and efficiencies to today's complex marketplace. At the heart of Plato Partnership is the Plato Market Innovator, which we like to call MI3, which is our academic division. Our goal is to sponsor academic research to stimulate the debate around the future market structure design and help regulators and market participants make more informed decisions. Plato Partnership is very proud to partner with the academic community in sponsoring important academic research on European-related market structure topics. The work being done by the academic community is critical to fostering debate on market structure topics and helping to shape the future. I wanted to update the audience briefly on the great strides that Plato Partnership has made over the last 24 months on the academic side. I'm proud to announce that we have actually sponsored over 20 academic research papers during this time. You can find the completed pieces of work on the Plato website at platopartnership.com and watch for the release of new work over the next few months. Many of the academic pieces of work that we've sponsored have actually resulted in one-on-one conversations with policymakers to debate and understand the result of their findings. This is an important milestone as regulators and policymakers look to the world of academia for information to make more informed decisions. Over the last few years, European markets have witnessed major regulatory change with more change expected. We could enter, as I mentioned last year, into an era of regulatory fragmentation on back of Brexit, which would make trading even more complex in Europe going forward. Just last week in the US, we had the US SEC Chair Gensler made some comments that I found were very interesting. And he said that the SEC cannot take their leadership in capital markets for granted. New financial technologies and business models continue to change the face of finance for investors and issuers. More retail investors than ever are accessing US markets, and other countries are developing deep competitive capital markets as well, seeking to surpass America. And the reason I mentioned SEC Chair Gensler's comments today is that I think that Europe has a great opportunity to become the gold standard of capital markets over the next few years, if we get it right. And as we come out of this post-COVID environment, we will witness a new wave of technological innovation and potential changing of business models. And this should allow European markets to be an area of major excitement for members of our industry and as well for academics to focus on. With this great opportunity for great change in our industry, Plato Partnership believes it's important to take a truly collaborative approach to enhance the reputation of markets and improve the experience for the benefit of all market participants. Building a strong bond between industry practitioners and the world of academia is extremely important to help building a stronger financial ecosystem. And we hope events like this are the first steps in achieving that milestone. So today and tomorrow, we actually have a fantastic agenda over the next 2 days. We have many interesting presentations that we believe will be extremely thought-provoking. We also have an all-star panel tomorrow discussing the European Consolidated Tape, which is at a critical stage in conversations. And before I hand off to Carole, I just wanted to say a few words of thanks, if I could. I wanted to thank the many members of Plato Partnership that helped bring this event to life today. I also wanted to send out a special thanks to Nita Carpi, the Chief Marketing Officer of Plato, for all the great work and hard effort going beyond the call of duty to bring this event to life. I wanted to also thank in advance our esteemed presenters today and tomorrow for their support. It's an honor and privilege to have you with us today. And lastly, I wanted to personally thank Professor Carole and Comerton-Forde for all of her outstanding work that has gone into creating today's event. I also wanted to thank Carole for all the hard work and dedication that she has contributed to Plato Partnership and the Plato Academic Division. So with that, I'd like to formally introduce Carole Comerton-Forde, Professor of Finance, University of Melbourne, and an academic advisor to Plato Partnership. Carole, thank you so much.
Excellent. Thank you very much, Mike, for the introduction, and good morning to everyone, or good evening, depending on which part of the world you're joining us from. A little bit of detail as to how the sessions are going to run for the next couple of days. So for those of you that have not been to an academic conference before, normally in an academic conference, we start with the presenter presenting their work. And after that, another academic will discuss and critique that work. So we're adopting that model here. So the sessions will be 30 minutes for the presenter and then 10 minutes for the discussant, followed by a 5-minute Q&A, which I will moderate via a web chat. So feel free to send through questions at any point during the presentation, and I will ask those questions in that Q&A session. At the end of the first two papers, in order to get us a little bit closer to an in-person conference, we have breakout rooms set up. So you'll be able to join one of two breakout rooms to go and have a more in-person discussion via Zoom with the presenter and the discussant if you want to ask further questions about the paper. So we hope that you'll avail yourself of that opportunity. So without any further ado, let's make a start for the first paper. So if we can bring up Thierry, perhaps. Our first presenter is Thierry Foucault, who's presenting a paper on Does Alternative Data Improve Financial Forecasting, the Horizon Effect? Thierry is a professor of finance at HEC Paris, and his discussant will be Shiyang Huang, who I will introduce after Thierry's presentation. So over to you, Thierry.
Thanks, Carole. Hello, everybody. I'm going to share my slides. So can you see my slides well? Everything is okay?
We can. Thank you.
Fantastic. So thanks for inviting me to give this presentation. This is based on a joint paper with Olivier Dessaint, with at INSEAD, and Laurent Frésard with the University of Lugano. And the paper I'm going to present today, or the results I'm going to present, is part of a broader research agenda on the effect of artificial intelligence and big data on financial markets, which is funded by the EU under an ERC grant. So the goal of this research agenda is really to analyze how big data is changing the way information is produced in financial market and the way it is used. So as you all know, we are living in a world of data abundance, and investors have access to a growing amount of data and diverse type of data to predict and forecast returns, earnings, and so on and so forth. So for instance, they can use text from social media, geolocation data, credit card data, satellite imagery, search traffic on the internet, like clicks on news, for instance. All those data are sold by so-called alternative data providers. So let me give an example of alternative data. That's the type of data you can buy from some data providers that give you every day images of parking lots at specific stores of retailers. Let's say in the US, this would be a store of Walmart, for instance. And so you have images of the parking lot, so you can count the number of cars every day, the intensity of utilization of the parking lot, and with that information, you can try to forecast next quarter sales. That's just an example of the type of data that people can use in today's markets to forecast returns, to forecast earnings. And not surprisingly, we have seen a wide diversity of data providers, of firms selling this type of data. For instance, you have firms that specialize in selling so-called sentiment data from social media, firms that sell satellite images, like I have shown, for instance, geolocation data, and so on and so forth. With my co-authors, we have done some research on those firms, and what we show in our paper is that the number of those firms has been steadily growing over time. We have used, a catalog which is provided by JP Morgan of all data providers. And so we have used this catalog to try to trace back in time, those data providers back to 1995. And so as you can see, alternative data is not a completely new phenomenon. You have already data providers back in 2000, and the number of those providers has been increasing over time to more than 500 data providers today. So the message here is that the number of alternative data sets has been growing growing over time. So of course, one first question about alternative data is whether you have information in those data. And so for this paper, we have reviewed more than 25 academic articles that have been written on this topic. There are many academic papers on this question. That's of course one of the major questions for practitioners. And the answer is yes. All those papers that I mentioned in this table are showing that with different type of alternative data, social media data, product review data, data from Google Trends, for instance, with all this type of data, you can forecast returns or earnings, for instance, or sales. But all those papers show as well that you have predictability for the short run, that is no more than 1 year, and beyond that, they say nothing. To my knowledge, there is no academic paper showing that you can use alternative data to forecast earnings, for instance, beyond 1 year, or to forecast returns beyond 1 year. It does not mean that this is impossible, but the fact that no paper has reported such a result suggests that there is no such information in alternative data. So in this paper, we claim, that's an assumption, that's an hypothesis, that alternative data is mainly short-term oriented data. And so the next question that the question that we have in this paper, given this observation, is whether the growth of short-term oriented data is good for financial forecasting. At the first glance, the answer seems to be obvious. If you have more information because of new data, and if the cost of accessing new information is lower because of all those providers of information competing together to provide the data, you would think that, well, everything is going to be better. People are going to be better at forecasting the future. Well, our main point is that, well, maybe not. Maybe not because if you want to value a firm, for instance, you will have to forecast short-term earnings, but you will have to forecast as well long-term earnings. And the fact that you have more information, more short-term oriented data, does not mean that you will become better at forecasting the long term. You might be better at forecasting the short term. We are going to show in the paper that this is the case, but what about the long term? And here, our main result, and maybe the most provocative result of the paper, is that, well, not only, the emergence of alternative data makes forecasters, those data make forecasters better at forecasting the short term, that's true, but the surprising result is that it may make them worse at forecasting the long term. You may think that maybe that this is going to change nothing for the long term. In fact, we find that this is not the case. We argue that theoretically, and we provide evidence of that the emergence of short-term oriented data is displacing the effort of producing information from the long term to the short term, and as a result, long-term forecasts become of lower quality. So I'm going to explain what some theory for that. We show that this may make economic sense. Of course, the theory is based on assumption. I will explain those assumptions. And we provide evidence. And the main contribution of the paper, I must say, is to provide evidence of the claim I just made. And for this, we need data on forecasters. And so what we do is that we use data on sell-side equity analyst forecasts. Why sell-side equity analyst? Well, there are many reasons for that. Let me highlight two reasons. The first one is that there is evidence that increasingly securities analysts are using alternative data to formulate their forecast. There is this paper by co-authors in the US who are using, by authors in the US, who are using analyst reports to count the number of times analysts refer to the use of alternative data in their reports. And what those guys show is that the frequency with which analysts mention the use of alternative data has been growing over time. So analysts use alternative data to formulate their forecast, not all of them, but some of them. And the second reason why we use sell-side equity analysis forecast is that there is a data set which is IBS that reports analysis forecast back to the 80s. So that gives us the possibility to analyze over the long run what has been the evolution of the quality of short-term forecast and long-run forecast for analysts. So let me now dive into the paper after this introduction. So there are two parts in the paper. There is a theoretical part, just to show that this idea that if you give to people more access to short-term information, you may get worse outcome for the long term in terms of forecasting. So this is what the theory is about. And then the main part, the second part of the paper, which is the main part of the paper, is about testing the prediction from the theory. So let me start with a very quick overview of the theory. The theory is quite complex. I'm not going to show you the math. I'm just going to show you the assumptions and the consequences of the assumption. So the theory is quite standard. We consider a model of forecasting. So we have one agent, the forecaster, let's say a security analyst, and the agent has to formulate forecasts about short-term earnings that will be realized at some date in the future, let's say date 2, and long-term earnings for a firm that will be realized in the long term, let's say date 3. And the forecaster, the security analyst, formulate a forecast about the short term and the long term at date 1. In order to formulate a forecast, that's just a number about what will be the short-term earning, what will be the long-term earnings. In order to formulate those forecasts, the forecaster is going to put some effort in collecting information prior to the formulation of the forecast. And there are two efforts to exert. One to obtain short-term information and one to obtain long-term information. That is information only relevant to forecast the long term. So that's the model. And what the model does is simply to solve for the optimal efforts that the forecaster should put at date 0 so as to get the best possible forecast to be quick. So these are the assumptions that we make. Those are the key assumptions of the model. Of course, these are just assumptions. You may disagree. Maybe that's not the way things work in reality. That's just a theory, a model. So our first assumption is that forecasting short-term and long-term earnings are related but distinct tasks. That is, you need to put different type of efforts to forecast the short-term and the long-term. The second assumption is that effort pays. That is, if you put more effort on one task, on the collection of one type of information, you are going to get a more accurate forecast for one specific horizon. If you decide to put more effort in collecting short-term information, your forecast of short-term earnings will be more accurate. Third assumption is that effort is costly. Effort has some benefit, but it has some cost. That makes sense. This is a standard assumption in economics in this type of problem. Where we diverge, this is the fourth assumption, we assume as well that multitasking is costly. That is, the more effort you put on one task, let's say if you decide to put more effort on collecting information to predict short-term earnings, the more costly it's going to be to work on the other task. That's a key assumption of the model. Multitasking is costly, and this is where we deviate from the standard formulation of the problem I'm describing here. Last assumption that we make is that the availability of short-term oriented data is going to reduce the cost of obtaining short-term information. That's a standard assumption by economists about alternative data. When you have all those assumptions, you can solve the model and you can get the following result, the following implication. What we show is that the availability of short-term oriented data is going to induce forecasters to optimally increase their effort to produce short-term information. Not a big surprise. If the cost of producing this information is lower, you are going to put more effort into getting this information. But I do not need the model to make this point. The more interesting prediction is that because of the multitasking cost, because people put more effort in getting short-term information, they are going to reduce their effort to get long-term information. There is nothing suboptimal. That's the optimal way to behave in the model. That's just equalization of marginal benefit and marginal cost. But because of that, analyst forecasts are going to become more predictive of short-term outcomes and less predictive of long-term outcomes. Their forecasts are going to be less informative about the long run. Optimally less informative about the long run. So how do we measure informativeness in this setting? That's going to be important. This is the only formula I'm going to show, but it is important to understand how we test the predictions of the theory I have just described. Well, we introduce a new measure of analyst forecast informativeness, which is based on the R-square of a regression. And this measure is the following. You can see R-square as an index of the quality of a forecast by a given analyst at a given horizon H, let's say in 2 years from now. This is simply the difference between the uncertainty about future earnings at this horizon, uncertainty being measured by a variance, that's a statistical way to measure uncertainty, minus the uncertainty about those earnings conditional after observing the analyst forecast, scaled by prior uncertainty. So this is an index, this is between 0 and 1. The larger is R-square, the more informative is the forecast of an analyst at horizon H. And the intuition is very simple. If the forecast is perfect, after observing the forecast, you face no uncertainty at all. The forecast is perfectly informative. R-square is going to be equal to 1. If the forecast is just noise, then it does not contain any information. It does not help in reducing uncertainty about earnings at horizon H. This difference is going to be equal to 0. R-square is going to be equal to 0. So this is R-square. It's just an index of the quality of a forecast by a given analyst. The nice thing is that for those who know about statistics is that this R-square can be obtained empirically by just running a regression of future earnings at horizon H on the forecast of an analyst. So I can measure this ratio empirically. I can measure this index empirically. This is the nice thing with my measure here. So how do we do that? So let me move to the empirical part of the paper. So we use US sell-side equity analyst reported, we use US sell-side equity analyst earnings forecast reported by IBS over the following period, 1983 up to 2017. So this is a very rich data set. We have many analysts, we have many forecasts by analysts. Many stocks are covered in this data set anyway. And for each analyst in the data set, on every day in the sample, so we have many days, that's a very long time period, we run the following regression in the cross-section of stocks covered by an analyst. Let's consider one analyst. She's covering 8 stocks. So every day for the 8 stocks covered by the analyst, we are going to run a regression of the earnings of the realized earnings of each stock at some horizon, let's say in 2 years from now, on the forecast of the analyst for the earnings of this horizon. Everything being scaled by firm size to try to control for the heterogeneity in the size of firms covered by the analyst. This is one way to get an empirical estimate of what I have called R-square. The R-square of this regression that I run every day, this is a very intensive empirical exercise, is an estimate under some condition of this thing, of this measure of informativeness. What do we obtain? Let me show you first that this makes sense, that what we obtain makes sense. Here, I'm showing very aggregated results. I'm averaging all those indices, all those measures, all the R-square I have obtained for each analyst in the sample over the entire sample. And I report the average by horizon, ranging from the very short term, let's say maybe earnings that are going to be announced in 1 month, to the very long term, 5 years. And what this picture is showing is what we call the term structure of analyst forecast informativeness. And it shows something which is very intuitive. Analysts are much better at forecasting the short term than at forecasting the long term. By observing their short-term forecast, on average for analysts in our data set, you reduce by about 85% your uncertainty about what will be earnings in the short term. But for the long term, you reduce your uncertainty on average by only 35%. That's still quite good. When I saw this result, I was surprised, frankly. I did not think, that analysts were informative, analyst forecasts were informative about the long run. They are, but they are not as much as for the short term, which makes perfect sense. Our paper is not about that. That's an interesting fact, but that's something you could have guessed without the model. Our paper is about how this thing is changing with data abundance. So let me show first how the term structure of analyst forecast has changed over time with the emergence of alternative data. So let me show you the long-run trend. Of course, just here, there is a lot of heterogeneity. I'm just showing the average across all analysts, all years. But there is a lot of heterogeneity in the data. So remember that over time, the number of alternative data providers has increased. So a basic implication of our theory for the long-run trend is that we should see an improvement in the quality of short-run forecast. These things should move up, and a deterioration of the quality of long-term forecast. These things should go down. Is it there in the data? Yes, it's there. So for instance, this line, the red line here, shows you the trend for the quality of analysis short-term forecast, less than 1 year. So as you can see over time, since 1983, this quality has improved. Analysts have become better at forecasting the short term. But they have become worse. This is the second line here. They have become worse at forecasting the long term, more than 2 years. Perfectly consistent with my theory. That's another way to show the same results. What we do is that we estimate every year the slope of the term structure of analysis forecast. So this is the same picture as the one I have used at the beginning, but year by year. And so here, what this graphic is showing is the evolution of this slope. So as you can see, it becomes more and more negative. That means that the term structure of analysis forecast informativeness is steepening. Again, that's perfectly consistent with my theory. But of course, there are many reasons why this could have happened. And over the last 30 years, many things have changed in the way analysts produce their information. And so you may come up, I'm sure you are going to come up with many alternative explanations. So just to better connect, this result with my theory, what we do as well is that we show that this trend, which varies across industries, that's something I do not show here, but if I do the same exercise industry by industry, you are going to see heterogeneity in this trend. There are industries where the steepening of the term structure is much stronger. And so what we try to do in the paper is to show that this heterogeneity is explained in part by the growth of alternative data. So how do we do that? Well, we use again the IBES data set. In this data set, you can have access to analysis reports back to year 2000 in this case. And we look at the reports and we count the number of times analysts in those reports mention the use of alternative data. And we do that industry by industry. And so we build industry by industry an index of alternative data usage by analysts, as mentioned in their reports, back to year 2000. And we show, this is what this table is showing, but I can just explain what it means with this graphic. We show that this trend here is stronger. That is, the steepening of the term structure of analysis forecast informativeness is stronger in those industries, for those analysts who are covering industries in which analysts use alternative data more. So there is a connection, even though this long-run trend may be due to many factors. What this table is showing you is that there is a connection with the use of alternative data. That's the first piece of evidence in favor of my theory. But of course, correlation is not causation. There might be, again, many things that could explain this table. And so if I try to publish this paper, I will be killed by referees. So we have to do more. And so what we did is to provide more convincing evidence for an academic audience by looking at a shock. By looking at a shock that changes the amount of alternative data to which analysts have access. So this shock is the introduction in 2009 of a new social media which is called Stop Tweets, which is dedicated to financial markets. That's a social, StockTweets is a social media where investors can share information, opinions about stocks, US stocks. So this is like Twitter for stocks, if you wish. So this has become the major social media for US markets. And we obtain from StockTweets access to all the messages posted on the platform from 2009 to 2017. The nice thing for us is that 2009 is a shock. There is before and after. And after 2009, we argue that analysts have access to more information from this particular source. So, of course, the first question people are going to ask is, yes, but analysts do not use this thing. Well, they do. They do. In fact, StockTweets has been integrated into a major aggregation, into the platform of major data vendors like Bloomberg, for instance. And what we show in the paper is that analysts are more likely to revise their forecast or to make new forecasts about a stock on the day following intense discussion about this stock on StockTweets. That suggests maybe they are looking at StockTweets. And we show also using biographic information about analysts in IBES and in StockTweets that there are 35% of the names that are present in IBES that are present on StockTweets. So we think that analysts are following StockTweets. Is StockTweets data short-term oriented? Yes. We show that with our StockTweets data, those messages I have mentioned before, we can predict earnings, firm earnings, up to 1 year, but no more than that. So again, that's just one particular type of alternative data. It is short-term oriented, as I have assumed in my theory. Okay, so how are we going to use this shock to test the main prediction of the theory? The main prediction of the theory is that if you give more short-term oriented data to an analyst, the analyst is going to be better at forecasting the short term. The R-square of the analyst is going to go up for the short term, but worse at forecasting the long term. One way to check that empirically is to run the following regression. That's a panel regression where for each horizon H, we fix the horizon, short term, long term. We regress for each analyst on each day or measure the informativeness of the analyst forecast on one measure of the analyst exposure to data coming from StockTweets. And here the idea is very simple. If one analyst in our sample is more exposed to StockTweets, then we should see an improvement in the quality of a short-term forecast relative to analysts who are less exposed. Everything is relative. And a deterioration, so lambda H should be negative. That's what that means, a deterioration of our forecast for the long term. That's not an obvious prediction. The sign of lambda H, this coefficient, should depend on whether you are looking at the short term or the long term. That's far from obvious. I could not have put this prediction without the theory. So here we exploit a lot I need to explain what I mean by data exposure. And here we exploit a lot the fact that there is a lot of heterogeneity in the coverage of stocks by StockTweets. There are stocks on StockTweets that are discussed a lot, for which you have many messages, and for which many investors express an interest, say that they are following many StockTweets users say that they are following the stock. And there are stocks which are not followed at all. So that means, that there is heterogeneity in the exposure of analysts to StockTweets, to the shock I'm considering here, depending on the portfolio of stocks that they are covering. And so in order to estimate this coefficient, we exploit this heterogeneity. We have to make sure that data exposure, what I call data exposure, really captures information produced on StockTweets, not information coming from elsewhere. So how do we do that? Well, we built our measure of data exposure to make sure that this is the case. So I will be quick here, but we use two measures of exposure. The first one is the number of StockTweet users who say that they are following a given stock. That's one way to measure the exposure of a stock to the information produced by on stock tweets. And the second measure is very intuitive. That's the number of messages written every day about a stock. But of course, this second measure, the problem is that clearly the number of messages written about a stock on a given day is going to be correlated with other news, maybe even with analyst recommendation. So that will be a problem. So we do something a little bit more complex than that. I will skip the details, but we built our measure of the number of messages in such a way that it does not reflect, it does not correlate with news coming from the outside. It's really, we really try to capture information produced on stock tweets. This is what we call hypothetical messaging. And so we do that stock by stock, and to get a measure of exposure at the analyst level, we just average those measures of exposure across all the stocks covered by the analyst. That gives us an analyst level measure of exposure to information produced on stock tweets. What do we get? Well, we do many regressions, we estimate, this regression in many ways, but let me show you the main result here, just the main result. Well, we find support for the prediction, which is, we find that an increase in exposure to stock tweets for an analyst is going to improve the quality of a short-term forecast. This is the estimate of the coefficient lambda h in my regression. But it's going to decrease the quality of a long-term forecast. The lambda h for a long-term horizon is negative and significant. That's another way to show the same result. We show that exposure to information on stock tweets is going to steepen the term structure of the informativeness of the forecast of a given analyst. Not by much. Of course, I will not expect, stock tweets to have a big effect. Not by much, but the effect is there. And last, this is the last result I will mention for today. What we show is that, our theory has additional prediction. It says that the effect that I'm describing should be stronger, especially for analysts covering stocks for which earnings are not much autocorrelated over time. Why? Because in this case, the production of short-term information is not really useful for the long term, or even less useful for the long term. And our second prediction is that the problem I'm describing should be even stronger for analysts who are facing a higher cost of multitasking. Who are those analysts? Well, we conjecture that those might be analysts who are following many stocks, a large number of stocks. So we predict that the effect I'm describing here, for instance, the steepening should be stronger for analysts with a larger cost of multitasking, or analysts following stocks with earnings that are less autocorrelated. And yes, we find exactly that. Okay, so just to conclude, that alternative data make security analysis forecast better. Well, our main point is that this depends on the horizon. Yes, for the short term, not for the long term. And I think that the overall message is more about alternative data. I think this raises an interesting question about the effect of alternative data on the economy in general. Alternative data are going to be very useful to predict the short term. We are not the first to show that. But is it going to be useful for the long term? Well, maybe not. And maybe that's a problem, because maybe if these detract people from forecasting the long term, we are going to have prices which are less informative about the long term. And that might make a market more short-termist. So these are things on which we are now working, but that's food for another paper. Thanks a lot.
Excellent. Thank you very much, Thierry. Our discussant for Thierry's paper is Shiyang Huang, who's from Hong Kong Business School. So thank you very much for joining us, Shiyang. Over to you.
Thanks, Carole and the conference organizer to invite me to discuss this interesting paper. I always like Thierry's research. So Thierry's work is always provoking and trendy. And I also learn a lot from this paper. Because Thierry has done a great job in presenting the paper, I will first quickly summarize what I learned from this paper. So what does this paper do? As we can see from the paper title, this paper studied how alternative data affect financial forecast for short-term earnings and long-term earnings. So this paper has both theoretical and empirical parts. To guide the empirical exercise, Thierry and his co-author first proposed a theoretical framework. In this framework, there's one analyst. This analyst needs to make a constant effort in collecting short-term information and long-term information. Now there's one important model assumption. It's about how to model alternative data. Thierry and his co-author argue that alternative data will reduce the cost to produce the short-run information. Okay, this is not an argument. Thierry and his co-author are extremely careful. They use empirical data to justify this point. Now, based on this framework, Thierry and his co-author show that alternative data can increase analyst effort in collecting short-run information, but alternative data will reduce analyst effort in collecting long-term information. So this result has an important implication for the informative of analyst forecast. Let's say alternative data will increase the informative of a short-term forecast, but it will decrease the informative of a long-term forecast. Okay, in the second part of the paper, the author empirical tested the theoretical prediction. Thierry and his co-author focus on US equity forecast. They have some novel and interesting findings. In a time series, Thierry and his co-author found that the informative of equity analyst short-term forecast is increasing over time. On the contrast, the informative of analyst long-term forecast is declining. And Thierry and his co-author push further. They provide strong evidence to show that these trends are at least partially driven by alternative data. Overall, I really like this paper. This paper is quite provoking. It provides new perspective to understand the impact of alternative data on financial markets. I particularly like the term structure of analyst forecast informative. Actually, this is also my first time to hear about the term structure of informativeness. Now, let me say, I have several comments to further improve this paper. My first comment is about how to tighten the link between the theory and the empirical exercise. Let me refresh your memory about the theory framework. In the current theory framework, Thierry and his co-author consider only two earnings. One is short-term, the other one is long-term. But however, in the empirical exercise, analysts need to forecast earnings for different horizons, such as 1 year, 2 years, 3 years, 4 years, 5 years. Now I have one natural question. How robust is economic intuition? I have been thinking about this question for a while. To check robustness, I work on one extension by myself. In this extension, I consider short-term, intermediate, and long-term earnings. Now, after I work on this extension, I'm quite comfortable to conclude that the economic intuition in this theory is extremely robust. More importantly, based on this extension, I find this extension has richer implication than I thought before. Okay, in the following several minutes, I want to talk a little bit about this extension. Okay, now in this extension, I assume firm generate three earnings: theta ST, theta MT, and theta LT. Theta ST is a short-term earnings, theta MT is intermediate earnings, theta LT is long-term earnings. Now, following Thierry's paper, I assume they are persistent component. So theta MT equals beta theta ST plus EMT. EMT is a shock to the intermediate earnings. Theta LT equals theta beta times EMT per ELT. Here, ELT is a shock to the long-run earnings. Again, the analyst compensation depends on the forecast errors. Now, to maximize her expected compensation, the analyst collect short-term information, SST, intermediate information, SMT, and the long information, SLT. Now, as Thierry's paper, the analyst chose effort to minimize the weighted average forecast error. Now, the effort in collecting short-term information is JST. The effort in collecting intermediate information is JMT. And the effort in collecting long-term information is JLT. I also consider a similar cost function as Thierry's paper. For example, there's substitution between effort in collecting short-term information and intermediate and long-run information. Again, A measures the cost in producing short-run information. We can imagine alternative data reduce A in this model. I follow Thierry's approach and solve the equivalent. Here, I don't want to talk about detail how I solve the model. But as we can see, this extension has 3 effort choice, 3 forecasts. Now, based on this extension, I start to check the robustness of Thierry's model. Thierry's has 2 theoretical results. The first one is related effort. The second one is about the pricing the informative of forecast. Okay, in the first step, I confirm that the first result is extremely robust. Let's say, when the cost of short-term information decreases, analysts will make more effort in collecting short-term information. On the other hand, they will reduce the effort in collecting long-run and intermediate information. In the second step, I re-examine the tensor slope of analyst forecast informative. But here, we have 3 earnings, 3 forecasts. So the tensor slope is quite different from Thierry's theoretical framework. So this is the reason why we need to check robustness. Now, as we have 3 earnings, 3 forecasts, so there are 2 slopes here. The first slope is the difference of R squared for intermediate earnings and the short-run earnings. So this is delta MT minus delta ST. The second slope is the difference of R squared for long-run earnings and intermediate earnings. This is delta LT minus MT. Okay, now how to measure the tensor slope, which is related to empirical exercise? Thierry's paper uses a linear specification to estimate tensor slope. So the most empirical relevant tensor slope is just average of this two slope. We call it the delta bar. Okay, now I confirm that this average slope is increasing with the marginal cost of short-run information. So this means alternative data will make a tensor of informative to become more downward sloping. So the key takeaway here is this intuition, the intuition from the theoretical framework is extremely robust and it fits empirical access very well. Why I use this extension to check robustness, I find that this extension has some interesting results. So this is related to the tensor curvature of analyst forecast informative. As we can see, there are 3 earnings, 3 forecasts. So actually, tensor curvature just compare the tensor slope for different horizons. Now, in this extension, I find the short-run information or alternative data have a large impact on the short-term slope. Okay, what I want to mention here is the Thierry's theoretical framework is quite provoking. We can develop a lot of other implications. Okay, now my second comment is empirical one. So overall, the empirical results are consistent with theoretical prediction. So Thierry and his course has done a great job. So alternative data increase the informative analysis short-term forecast, but it will decrease the informative of analysis long-term forecast. The economic channel is from analysis effort. But my question is, it would be great if Thierry and his course can provide direct evidence on the effort. I totally understand there's a big challenge. The challenge is how to measure analyst effort in collecting, for example, long-run information. Here, I have 2 suggestions. So potentially, the first measure can be really how timely analysts release their forecast for long-term earnings. As we know, analysts always update their long-term forecast after annual earnings announcement. In this sense, the time between annual earnings announcement and update of a long-term forecast can measure analysts' forecast effort in collecting long-term information. My second measure is based on conference call scripts. In the conference call, we know analysts play an important role. They play an active role, for example, particularly during Q&A sections. So Q&A section provide a lot of information for us to categorize how analysts make effort or how they are interested in long-run information. I download all US conference call scripts. And now I'm going to give you several examples to show you this is the case. The first example is about Apple's earnings conference call in the 3rd quarter of 2005. Now, during the Q&A sections, the analyst from Thomas Waits' partner, Mr. Hunt, asked a question. He asked, okay, So the second question is regarding the iPod and long-term outlook for the music business. Okay, as we can see, analysts indeed interested in Apple's long-term earnings. So this example shows that Q&A activity can help us to characterize analysts' interest in long-run earnings. Now, based on analysts' Q&A activity, it's indeed feasible to quantify analysts' effort in long-run information. But now we have one natural question. That is, does alternative data reduce analysts' interest or effort in long-term earnings? Now, the short answer is yes. To show you this is the case, I download all US firms Comerton-Forde. The sample period is from 2002 to 2020. I conduct a simple textual analysis. I just calculate percentage of Comerton-Forde in which analysts have an interest in long-term performance. Okay, now this percentage can represent analysts' interest in long-term fundamentals, and their interest definitely will be linked to the effort in collecting long-term information. After that, I plot a time trend over this percentage. So as we can see on the screen, this percentage is decreasing over time. This is a surprising consistent with the declining informative or analyst long-term forecast. So in a word, I think it's feasible for Thierry and his co-author to show how alternative data affect analysts' effort in collecting long-term information. So based on my own work here, the result seems quite promising. Now, my third comment is about implications. So Thierry discussed a little about implication at the end of presentation.
Shiyang, you might need to wrap up shortly. You're a little over time. So if you can just make this point quickly. Yeah.
Okay. Here, I just want to one implication is for asset management industry. As we know, in the asset management industry, hedge fund, mutual fund construct trading strategy based on analyst short-term forecast. Now, if we take Thierry's work very serious, when we construct trading strategy based on analyst short-term forecast, we should put more weight on this analyst. Okay. Now, I'm running out of time. Now, let me quickly conclude here. Overall, I think this paper is addressing a trendy and important topic in the literature. The empirical findings are extremely robust and solid. At the same time, this paper is quite complete. I have to say, this paper is very provoking and learn a lot from this paper. I can definitely see this paper will inspire many potential directions to go in the future. So I strongly recommend this paper to all of you. Thank you.
Terrific. Thank you, Shia. We have some questions. I think we've got time for one before we move on to the next paper. So Thierry, there's a question from Tristan Marshall from NBIM. He says, if you look only at the data since 2000, your graphs show no evident change in either short-term or long-term predictability of analyst forecasts, but the availability of alternative data has exploded over this period. Is this consistent with your hypothesis?
Well, first of all, let me thank Shiyang because he did a really great job. You know, the three comments are very well taken and very, very interesting, in fact. So to come back to the question, I'm not sure to understand which graph, because there is, you know, the number of alternative data providers is increasing over time, and it is true that the rate at which it is increasing is increasing, especially, you know, since 2010. And so what we show in the paper, I do not have time to show that, is that the steepening of the term structure of analyst forecast, the rate at which you have this steepening is also increasing over time. So that's consistent, you know, with this evolution. But I'm not sure this answers the question.
That's okay. I'm sure Tristan can follow up with you in the breakout room after. So thank you very much, both to Thierry and Shiyang for the presentation and the discussion.